Hi and welcome. Today we are going to look at integration by substitution and integration by parts under integral calculus. Are you with me? Yeah. So let's start. Please take your book, your pen and calculator so that we do this together, okay? So let's take example 1. Example 1 says find the integral of 10x multiplying x squared plus 3 all exponent 4 dx. Okay. So to integrate this, please pay attention. What you are going to do is, you let u be equal to what you have here, just what is in the bracket. You will include the exponent, please. Okay, when you see something like this, okay, you just let u be this one. Okay, now if you let u be equal to x squared plus 3, then you find du over dx. Okay, you differentiate u with respect to x. Okay, so when you do that, 2 multiplies this and gives you 2x, isn't it? When you subtract 1 from the exponent, you have 1, isn't it? So you have 2x. When you differentiate a constant, the derivative of a constant is 0, so it doesn't come. So from here, then you make dx the subject from here. Are you following? When you make dx the subject, dx will be equal to du over 2x. Let me prove to you why. Look at this place. You have du over dx, isn't it? Du over dx equals 2x. You see, 2x is the same as 2x over 1. So you can cross multiply. When you cross multiply, you have du equals du times 1 is du. Dx times 2x was 2x dx. Isn't it? 2x dx or ds 2x. Multiplication is commutative. So your interest, your main goal is to make ds the subject, isn't it? So you divide both sides by 2x, which is the coefficient of dx. So when you do that, this cancels this, isn't it? So you have ds to be equal to du over 2x. So that's what we've got in here. I hope that's clear. Another way of doing it is, you see, since this is over 1, are you with me? Since this is over 1, you reciprocate the both sides. Okay, when you reciprocate both sides, you have dx over du equals 1 over 2x. 1 over 2x. Then after doing that, you multiply both sides by what? The denominator of this, that is du, times du. So this du takes away this du, then you'll be left with dx over here equals 1 times du is du, isn't it? Over 2x. So it's the same thing. So after doing that, are you with me? Then you recall this integral. Okay, when you recall it, what you are going to do now is that in place of this, since you've let u be this, you substitute u in place of it. Okay, so you now have what? 10x u exponent 4. And also, you've made dx, you've been able to find dx, that dx is now equal to what? Du over 2x, isn't it? You've been able to get dx to be equal to du over 2x, isn't it? So you substitute this also in place of dx. So you have du over 2x. I hope you are following. Your main goal is to make u there, like to cancel out x totally. Okay, so you realize that this x cancels out this x, so it doesn't exist anymore. You don't want to have two variables together. One of them must give way. Do you get it? You must take away one of the variables. Do you get it? So this x has cancelled this x, so you now have one variable. And then 2 goes into itself once and go here 5 times, isn't it? So this will give you what? Integral of 5u exponent 4 du. Is that clear? So, you know, one of the properties of integration or laws of integration when you were studying, that you can factor a constant out. This 5 is a constant. You can factor it out and integrate this separately. Do you remember that? So you have this out, so you have 5 integral of u exponent 4 du. Are you following? So what you do next is to integrate u exponent 4. So integrating u exponent 4, you have u exponent 4, you add 1 to the exponent, isn't it? And divide by the new exponent, which is 4 plus 1, then plus c. Okay, since this is indefinite, you add plus c to it. Now, after that, then you simplify it. 4 plus 1 gives you what? 5, isn't it? 4 plus 1 gives you 5. So you have 5 multiplying u exponent 5 over 5 plus c. So this 5 can take away this 5, isn't it? So you have what? U exponent 5 plus c. Are you following? So this is your final answer. But listen, you are not going to leave your final answer like this. Though this is your final answer, but you can't leave it like this. Since you let u be equal to this, x squared plus 3, you need to come and substitute it back there. So that will make you have what? X squared plus 3 all exponent 5 plus c. So that is the answer to example 1. I hope that's clear. So let's look at example 2, integration by parts. What we did first was integration by substitution. Okay, example 1 was integration by substitution. So let's look at integration by parts. Now, to solve integration by parts, are you with me? Let us try something before we start solving. Let's say let's assume you want to use substitution for this. So let u equals x plus 4. X plus 4. Are you following? Now, when we find du over dx, du over dx will give us 1, because x is exponented to 1. 1 times this is 1. 1 minus 1 is 0. X exponent 0 is 1, so it's 1. Okay. Du over dx is equal to 1. If you make dx the subject, you get dx to be equal to du. Are you following? When you cross multiply, you get dx to be equal to du. Are you following? So if dx is equal to du, then you can now substitute that. Okay, then you have integral of 15x. Are you there? Multiplying u exponent 3 over 2 du. Now, have you realized that there is no x at the denominator here to take away this variable x? Have you seen that? If you look at the previous one, when we got to this side, when we got here, this x was able to take this variable away. Have you seen that? But in this one, there's nothing to take this x away. Are you following? It's not multiplication, it's x. There's nothing to take it away. So you can't easily use substitution, integration by substitution for this question. So you have to use what? Integration by parts. So that is what will lead us to integration by parts. So pay attention. So to solve integration by parts, let me clean this. Hold on, let me clean this. Let me erase this. I hope you understand that. Yeah. So let's take that. Let's proceed. So we are using integration by substitution. So to use integration by integration by part, this is the formula. uv minus v derivative of u. You know, there's a sign here, it means derivative of u. Okay. The formula is uv minus integral of v times derivative of u dx, or f of x times g of x minus integral of g of x multiplying the derivative of f of x dx. It's still the same formula. Here what you should know is that your u is f of x and your v is g of x, and g of x is v, and derivative of f of x is derivative of u. Okay, it's still same formula. Okay, always I usually use this. That's how I usually write it, because this was how I learned it the first time I was learning it. Okay, so the first time ever, this was the one I saw. So this is how I usually write it. But it's good. This is simple. You can write this as well. So what you're going to do here now is that listen, you let u, are you following me? You let u be equal to the first function here, 15x, okay? You let u be equal to 15x, and you also let derivative of v, not v, please take note, not v, but derivative of v straightforward, be x plus 4 exponent 3 over 2. Be very, very careful and vigilant when you are solving this. Not v, but rather the derivative of v, let it be equal to x plus 4 all exponent 3 over 2. So after doing that, the next thing to do is to, since you know u to be 15x, find derivative of u, okay? When you find derivative of u, you will get 15. When you differentiate u, okay, you differentiate u with respect to your x, that's du over dx. Du over dx, which is written as u derivative, is what? Is 15, isn't it? Then after that, you know, you have x plus 4 all exponent 3 over 2 to be derivative of v. So to convert this derivative of v back to v, you have to integrate this. Are you following? So when you integrate this to get v, you have x plus 4 all exponent 3 over 2, then you add 1 to the exponent and divide by what? The new exponent, which is 3 over 2 plus 1. Are you following? So that will give you what? Now, 3 over 2 plus 1 gives you 5 over 2. Okay, 3 over 2 plus 1 gives you 5 over 2. So here too is 5 over 2. But you have 1 here. Are you following? You have 1 here. 1 divided by 5 over 2 gives you 2 over 5. Okay, that's why this place changed to 2 over 5. 1 divided by 5 over 2. You know, 3 over 2 plus 1 is 5 over 2. So 1 divided by 5 over 2 gives you what? 2 over 5. So that's when the 2 over 5 comes. Then you have your x plus 4 all exponent 5 over 2. So this is v. So this particular one is our v. Okay. So we now know derivative of u and we know v now. So we can now use the formula, isn't it? So using the formula, you are going to substitute u in place of u. The formula says u times v. So what's our u? Our u is 15x, isn't it? Times our v is what? 2 over 5 multiplying x plus 4 all exponent 5 over 2. So you also substitute it there. Minus integral of v times derivative of u. What's our v? This is our v, right? So you substitute it there. Times derivative of u. And derivative of u was 15, isn't it? So you substitute it there. Dx. Are you following? So after doing that, the next thing to do is that, you see, 15 can multiply 2 over 5 to give you 6. Or here too, 15x times 2 over 5 will give you 6x, because 5 goes here once and go here 3 times, isn't it? So you have 3x times 2, which will give you 6x. Then you have your x plus 4 all exponent 5 over 2. Minus, now we are going to integrate this. Okay, we are going to what? Integrate this. To integrate this, are you with me? Already this times this, 5 goes here 1 and go here 3 times, right? 2 times 3 is 6, so this already gives you 6 written down. Okay, 2 over 5 times 15 is 6 already. So we integrate this. Okay, we integrate this. This is a constant. 2 over 5 times 15, which is 6, is a constant. So we integrate this. So when we integrate this, it means that we are going to add 1 to the exponent and divide it by what? The new exponent, which is 5 over 2 plus 1. 5 over 2 plus 1. So 5 over 2 plus 1 gives you 7 over 2. Okay. All divided by 5 over 2 plus 1 gives you 7 over 2. Have you seen that? Plus c. Then you get 6x multiplying x plus 4 all exponent 5 over 2 minus, now 6 divided by 7 over 2 should give you 12 over 7. Please use your calculator for it. Okay. Then multiplying x plus 4 all exponent what? 7 over 2 plus c. So that is the final answer to this also. If you can simplify it further, no problem, you can. But if it doesn't look like you can simplify it further, then you leave your answer as such. Are you with me? You leave your answer like that. Okay, so that's the final answer to this as well. So this is how we do integration by part. So let's look at example 3. Example 3 says integrate 5x over x minus 1 square. This one too, you can try it just like the way I show you this. I tried using substitution for this and it doesn't work, and I use this. Try using it also, you see that it won't work. Okay, but before you do that, there's something you have to know about integration. You have to be very careful. When you have, let's say, a over b, you know a over b, maybe you can't integrate it easily. Just convert it to a b exponent negative 1. Okay, a over b can be converted to a b exponent negative 1. When you have x divided by x plus 2, okay, let's say all exponents 2, it can be converted to x into bracket x plus 2 all exponent negative 2. So you should know this thing, it's very important. So you can apply it here that it will become 5x multiplying x minus 1 exponent negative 2, okay, dx. So using the integration formula, integration by parts, okay, using the formula this or this, what do? We let u be what? 5x, isn't it? This 5x, we let u be this, okay. Then we also let the derivative of v be x minus 1 exponent negative 2. Are you following? So if that is the case, we can find the derivative of u by differentiating u, isn't it? And it will give us 5, isn't it? And when we integrate this particular one, okay, we can get v. When we integrate this, we'll get v. So let's integrate it. How do we integrate? We add 1 to the exponent and divide by what? The new exponent, which is negative 2 plus 1. So that's what I've done over here. So negative 2 plus 1 over negative 2 plus 1. So you have what? Now, negative 2 plus 1 gives you negative 1, isn't it? And 1 over negative 1 is still negative 1. Times x minus 1, all exponent what? Negative 1. You get it? Negative 2 plus 1 is negative 1. So this is your v. So we are going to substitute it into the formula. So the formula says uv, isn't it? So what are u? Our u is 5x. What are v? Our v says negative 1. You know, there's no need writing the 1. So let's say negative into bracket x minus 1, all exponent negative 1, isn't it? Minus integral of v times derivative of u. So what are v? Our v is negative 1 times x minus 1, all exponent negative 1, times, what's the derivative of u? The derivative of u was 5, isn't it? This. So we'll substitute it here. So it gives us 5 dx. I hope you are following. Then we can now simplify further. So this gives us what? You know, 5x times negative, let's say negative 1, it gives you negative 5x, isn't it? Then bracket open, x minus 1, all exponent negative 1. Are you following? Minus integral of, now you have a 5 here. You can use this 5 to multiply negative 1 that you have here to give you a constant negative 5, times x minus 1 all exponent negative 1 dx. I hope you are following. Then you have your negative 5x multiplying x minus 1 all exponent negative 1 plus. Now you can factor this negative 5 out. Since it's a constant, you can factor it out so that you can integrate this. So when we factor negative 5 out, you have a negative here. This negative 5 will multiply the negative over here to become positive 5. Please be very, very careful with negative. Okay? Be very, very careful with what? Negative. One bad nut destroys the other. So this negative can spoil the whole work. Do you get it? If you don't take time. So be very careful with multiplications of negatives. Negative times negative gives you positive. You should know that. Okay? So this negative and this negative gives you positive. Do you get it? So then integral of x minus 1 all exponent negative 1, isn't it? So now let's integrate x minus 1 exponent negative 1. Are you following? So when we do that, this remains plus. Now, let me remind you of something in integration. Whenever you are integrating, let's say x exponent negative 1, are you with me? Under normal circumstance, are you with me? It should have been what? X exponent negative 1. You add 1 to the exponent, isn't it? Divided by the new exponent negative 1 plus 1. Are you following? Plus c. Now, when you do that, you have x exponent negative 1 plus 1 gives you what? 0. Are you with me? Negative 1 plus 1 gives you 0 plus c. Can you divide something by 0? You just take your calculator and press 3 divided by 0. You see that your calculator will tell you undefined or mass error. Are you following? So we don't do that. So whenever you have such a situation, whenever you have this kind of case where it is exponented to negative 1, are you with me? It should become ln. So when you are integrating x exponent negative 1, it should become natural log, that's ln of x. Ln of absolute value of x. Okay. Or ln of x. So that's what it should give you. Okay. So that's what we have here. So it should give you plus ln of x minus 1. Okay. Plus your c. 5 ln of x minus 1. Okay. Look at it. Sorry. Integral of x minus 1. All exponent negative 1. You realize that it will give you x minus 1. If you had wanted to follow the normal way of doing it, you have x minus 1 exponent negative 1 plus 1 all over negative 1 plus 1. And this will give you 0, this will give you 0. So it's not feasible. It's not cool. So this is the only way we have to do it. Whenever you have exponent negative 1. So it gives you natural log ln of x minus 1. I hope that's clear. So that is example 3. So I want you to try this. Try this. Make sure you try it. It's an examinable question. It's always in exams. You see this kind of questions in exam. This is definite integral. Okay, and this is indefinite. So but just apply the whether integration by substitution or integration by parts. Use either of them that is feasible, that works for you to solve it. After solving, then you can now substitute your 5 and the 1 according to the definite integral rule. Okay. Then for this, be very careful. The 6x, you let the 6x only be u. And then you let the e exponent x plus 7 be derivative of v. So you should know how to solve that. Okay. So thank you for watching. Bye. Please remember to subscribe to my YouTube channel and also share the link with others. Okay. Thank you for watching.